This clip will cover casing standoff functionality within Innova Engineering. So the casing standoff calculation uses the data input by the user and calculates one of two things. Either the casing standoff based upon a given centralizer spacing entered by the user, or the alternative is the required centralizer spacing to achieve the user's desired standoff. So based upon some step values input by the user, the optimum centralizer spacing will then be calculated. In order to run the casing standoff calculation, a torque and drag calculation needs to be run. So there is already a video for torque and drag setup. If you first consult that video and then come and view this one so that you're all up to speed regarding the layout required and inputs for a torque and drag calculation. In this case, I've got an example ING file that's pre-made up. We have the drill string input, and you'll note that there are multiple different sections of the same liner. So this is the same grade liner, but the difference here is that they've got different centralizer spacings and different centralizers on. And because of that, you have to break them down into individual components. The important details to look out for here are the centralizer spacing. If you are not running the optimize standoff function, then the spacing is what the software bases its calculation upon for each component. The centralizer OD for rigid centralizers, that is the fixed OD of them. For bowstring stabilizers, that is the maximum bowspring diameter, and that can be larger than the ID of the well bore in the bowspring centralizer case. The length, blade width and blade count are only used in hydraulics. They don't affect the standoff calculation itself. The bowspring restoring force is the force exerted by a centralizer against the casing to keep it away from the wellbore wall. So this input is used in the standoff calculation to determine how much the bowspring centralizer is deformed for a given side force. So the centralizer will never compress more than the body centralizer body OD, and the higher the side force, the more deformation of the centralizer. If nothing is entered within the bowstring restoring force cell, it's assumed that the centralizer in question is rigid. The centralizer body OD is the maximum body OD for the centralizer, i.e. the bit that is in contact with the casing. So for rigid centralizers, this is not an important value, but for the bowspring centralizers, this is the minimum absolutely 100% compressed value that bowspring centralizer can go to. The running force is the maximum force required to insert centralizer into a specified wellbore diameter. So this input is not used in the standoff calculation, but is used for torque and drag. So it will affect your pickup, slack off and reaming values. An important point to note with the running force is that it's not applied to the torque and drag calculation until the bowspring centralizer is 50% compressed or more. And between 50 and 100% compression, the amount of that force is proportionally applied higher. So that running force is the 100% maximum running force. The centralizer type is just for note and isn't included in any calculations. And then the running force restriction ID is the ID that 100% of the running force will be utilized in the torque and drag calculation. So when no value is entered here, the program will apply the running force to the torque and drag calculations based upon the amount of compression, remember that 50 to 100%, experienced by the bowspring centralizer at any given point in the wellbore. The more the centralizer is compressed, the higher the percentage of the running force which is applied. If the user enters a value here, the program will apply the maximum running force over any part of the wellbore where the ID is the same or less regardless of the compression. So if this is left empty, the running force will be applied only between 50 and 100% compression incrementally. If we put in a running force ID here, say of 16 inches, even though the compression would be higher than 50%, because we put 16 inches, at any point the centralizer experienced 16 inches or less, the 100%, i.e. 2.1 thousand pounds of running force would be applied. So those are the essential component details to input on your casing regarding the centralizer details. We also need to input the weld geometry, fluid properties, survey information, and engineering parameters. And because we're running a torque and drag calculation, and the byproduct of that is the standoff calculation, we need to input these parameters, select our surveys, and input the flow rate. At the start of this clip, I mentioned that there are two outputs or forms of the calculation. One is with the software optimizing a standoff for you and telling you the correct spacing. And the other is using the user input centralizer spacing within the component details section. If the user does not have this optimized standoff box checked, it will use the spacings in the component details. If the user has this optimized standoff checked, it will then go into the optimized standoff mode. And if you go to Tools, Standoff Optimization Parameters, this will be the desired standoff percent, which we can see down here, as well as the min step values and the max spacing values to run that optimized scanning against. In this case, we're not going to optimize standoff, we're going to run the calculation for the spacings that we've put in to our component details. I'll go Calculate, Torque and Drag. Now I can go to Torque and Drag Results, and either hit my standoff summary, which will generate a report for us, detailing the input parameters, and then a Centralizer Standoff Results section, giving us the depth, inclination, standoff mid-joint at the centralizer with the given spacings, restoring forces, running forces, side forces, centralizer OD, and the type of centralizer, as well as a couple of different charts itemizing the standoff and the side forces and centralizer forces, as well as the hook load chart. Or we can go to Torque and Drag Results, Snapshot Charts, and Casing Standoff. And this will give us a number of series pertaining to the calculation. If I go to Engineering Parameters and select Optimize Standoff and rerun the calculation, it will use these parameters to calculate the optimized spacing for your centralizers to run on your casing for the best standoff to get to your 60% standoff. So we've run that calculation, standoff summary, and now we can see here that our standoff at the centralizer and mid-joint is 60% or greater, and it gives us a breakdown for the centralizer spacing that we should be using in order to achieve that. Only mild difference here is that on the casing standoff chart, we now have an optimized spacing series, and the centralizer spacing line in yellow has become the recommended spacing line. So that very quickly is the brief introduction to casing standoff within Innova Engineering.